What if the most profound mysteries aren't in space, but right here on Earth, hidden beneath miles of crushing water? We've always looked upwards for wonder, yet below the glittering waves lies a world so little understood that it may be as well another planet. Humanity has charted Mars in exquisite detail, mapped asteroids, and probed cosmic background noises. But we've explored less than 6% of our own ocean floor. Down there, beneath the weights of continents, strange sounds ripple, untraceable colossal sounds. Lights shimmer where light shouldn't exist. Pressures rise beyond endurance, and still something moves, producing signals that defy explanation. This isn't science fiction. There are data points recorded by humans, sounds captured by underwater microphones, energy pulses logged by machines, anomalies no one has fully decoded. In this episode, Unsolved Deep Sea Anomalies, Ocean's Cryptic Signals, we'll dive into what scientists can't explain, the strange voices of the abyss, the flickers of impossible light, and the faint pulses that hint that the ocean itself might be communicating. Our journey begins not among the waves, but in the deep silence below them. Imagine yourself sinking beneath the surface. The sunlight fades within minutes. Blue turns to navy, navy to black. The pressure multiplies until it could crush a submarine. A mile down, it's colder than the Antarctica in winter. This region, the abyssal zone, extends thousands of meters downward and covers more than half the planet's surface. It's vast, dense, and almost entirely unvisited. Instruments malfunction here, signals fail, navigation drifts into chaos. Communication doesn't just break, it dissolves. Radio cannot travel underwater. Sonar echoes become distorted. Equipment loses calibration. The deep denies observation. Strangely, our most valuable recordings began as a byproduct of war. During the Cold War, military hydrophones, underwater microphones spread across the Pacific, were created to detect submarines. Decades later, scientists examined decades of that archived audio for environmental research. Hidden among known sounds, whales, subcrashes, cracking ice, were frequencies that matched nothing familiar. The more the data was filtered, the stranger it grew. Powerful, patterned noises came from regions where nothing should move at all. These findings mark the start of humanity's strange relationship with the unknown beneath us, a relationship that continues to deepen with every unexplained signal. In 1997, a low, thunderous rumble trembled through wide stretches of the Pacific Ocean. It rose rapidly, echoing louder than any recorded sound of biological origin. NOAA researchers nicknamed it the Bloop. The sound's volume dwarfed even that of a blue whale's call. Early analysis suggests a living creature, but no known species could produce that amplitude. Speculation spun wildly. Some theorized enormous marine mammals undiscovered by science. Others pointed to collapsing icebergs snapping under pressure near Antarctica. Yet some inconsistencies lingered. The bloop's tonal curve didn't match glacial fractures, nor did its reverberation behave like ordinary ice movement. It seemed organic, but too massive, mechanical, but too fluid. Scientists studied spectrographs again, patterns repeated precisely, separated by equal time intervals, an oddly structured rhythm. Could nature produce such precise modulation? Possibly. Could we recognize it as communication? Not yet. Years after the initial detection, sub-recordings appeared in unconnected ocean regions, weaker but similar. Whatever the source, it demonstrated scale, an event spanning an entire ocean. Official statements lean towards natural explanations, but the honest scientific record ends with the one word: the unknown. The bloop remains unexplained, one of Earth's greatest acoustic enigmas. Following the bloop, additional signals emerged. Each bore a character of its own. In 1999, Julia was captured, a stretched, low moan that lasted minutes. It rose and fell as though something vast exhaled in exhaustion. Then came the train, recorded as a rhythmic acceleration, repetitive thuds increasing in tempo, steady and deliberate, as if motive. Another, the whistle, producing a rising, clear tone that oscillated precisely. Its spectral markers hinted at mechanical regulation, a signal rather than a drift. Scientists lined these alongside known ice, seismic, and biological sounds. None matched completely. Instead, they displayed consistency, a deliberate pacing rare in natural systems. Some recorded across thousands of kilometers simultaneously, implying scale so large that it could only belong to ocean dynamics or something beyond. Certain researchers propose resonance. When planetary crust shifts beneath vibrational tension, water channels may amplify low frequencies like organ pipes. Others noted how the patterns resembled cyclic fields in electronics. No definitive theory emerged. The recordings joined archives of unexplained data, faintly organized, strangely familiar, and always haunting. Listening to them, you sense structure, not chaos, not randomness, but rhythm. It feels, for a lack of a better word, composed. Light cannot survive deep descents. By 3,000 feet, sunlight dies completely. Beyond that, the ocean becomes a permanent night. Yet, paradoxically, cameras have captured illuminations down there. In 2018, a remote submersible exploring near the Mariana Trench recorded 15 pulses of bluish light, evenly spaced across several meters of nearby ridges. The pattern lasted seconds. When replayed frame by frame, geometric alignments emerged. Scientists were baffled. Too regular for biology, too clean for malfunction. Known luminous creatures such as jellyfish or bacterial plumes produced drifting glows, uneven organics. The recorded flashes were different, sharp, coordinated, like measured strobe intervals. Some suggested phasoelectric phenomenon, quartz crystals releasing photons under stress with tectonic plate grind. Yet this occurs as diffuse shimmers, not distant beams. Others invoked bioluminescence colonies reacting in synchronicity to the vibrations. Each theory solved fragments, never the whole. The precise distance between pulses, the perfect timing, the absence of mechanical interference, these remained unsolved. The event repeated once in another trench site months later. Again without cause, lights in absolute darkness challenged not just physics but perception. Are we seeing chance alignment or a deliberate pattern? The answer still waits in black water. Occasionally, sensors detect something even stranger. Immerse displacements in water pressure, as though an unseen bulk shifts slowly across the seabed. In 2015, near the Karametic Trench, hydrophones recorded a pressure wall several kilometers wide moving east for nearly 20 minutes. No seismic activity was accompanied by it. No volcanic plume, no landslide. Afterwards, data showed identical displacement in multiple arrays, tracking coherent movement. If this were geological flow, seismometers would have spiked. If organic, it was far beyond any known life form. The event became known simply as the moving mass. Scientists ran models. Could dense plumes of gas or warm current mimic such readings? Only partially. The pattern's edges were too defined. Actively moving ridge sediment should scatter data, but the record showed uniform translation as if a shape with boundaries. A few speculative voices suggested giant colonial mats, living networks adapting visibility through sonar absorption or density mimicry. In biology, octopuses use light for camouflage. Perhaps in the abyss, matter evolved to manipulate sound itself. No physical evidence surfaced, still those readings persist in archives. A movement without form, presence without appearance, hinting that invisibility needed be optical, but it also can be acoustic. While sound and movement leave striking markers, energy signatures carry their own mystery. Deep monitoring arrays occasionally register electromagnetic flickers without mechanical cause. The most notable occurred in 2012 near Chile's coast, a massive spike lasting less than 3 seconds, powerful enough to trigger distant sensors but leaving no temperature increase. Then, 10 hours after, faint repetitions appeared every 33 minutes with mathematical precision. The phenomenon's synchronicity across sensors over thousands of miles apart defied coincidence. Engineers checked for solar interference, equipment errors, satellite reflection. Nothing matched. Some theories suggested mineral stress causing localized electric discharge through conductive brine. Yet, even then, frequencies should have been irregular, not perfectly timed. When patterns repeat with clock-like order, scientists hesitate to dismiss them. Systems that exhibit rhythm but lack mechanical origin challenge our categorization of natural events. Whether internal planetary response or unexplained form of plasma release, these energy bursts reveal that the ocean is not static. It's a living circuit, translating tectonics, magnetism, and heat into waves we barely noticed above. Most people underestimate how little we know about the ocean. Though it covers 70% of Earth, less than 1/10 is mapped in any detail. Even modern mapping relies on satellites, inferring depth from gravity, not direct measurements. At extreme depth, sonar signals blur, pressure warps electromagnetic readings. The abyss resists direct study. Imagine trying to map a canyon while being blindfolded, feeling outlines with fragments from echoes. That's the state of oceanography today. This blindness guarantees surprise. If something vast or unconventional existed in the deep, whether geological system, biological colony, or complex resonance, chances are we'd never notice. Every new expedition reveals oddities. Shapes mistaken for ridges turn out to be fluid vents. Black zones turn into luminous underthermal imagery. Discovery itself has become an expectation. Our tools, immersive but limited, are designed for our surface environment. In the deep sea, Earth's own physics rewrite instruments' rules. This means mystery isn't the exception, it's the default. Sometimes the only rational response to the unexplained is humility, accepting that our perception is still quite literally shallow. Place all recorded anomalies together, and coincidence begins to thin. The Bloop's origin zone overlaps with unusual light fluctuations. Energy surges cluster near tectonic interactions, generating rhythmic sound. Some researchers now suspect a complex connected system, a feedback network stretching across the planet's aquatic crust. Earth's ocean conducts vibration extraordinarily very well. Waves of sound and energy can travel thousands of miles without disappearing. In seismology, this is noise. In communication theory, it's a perfect carrier. One idea, dubbed planetary resonance, proposes the ocean acts as a natural amplifier for tectonic pulses, releasing built-up strain harmlessly through giant sound waves instead of earthquakes. The light and electromagnetic activity might result from mineral stress, completing a loop of self-regulation. Still, these are only models. Data remains incomplete. We observe rhythm, reputation, synchronization, but not intent. The question is whether order requires intention. Can a system behave intelligently without being alive? Perhaps the ocean's anomalies are Earth's version of thought, mechanical yet meaningful, echoing through a medium vast enough to imitate consciousness. From bacteria to whales, intelligence scales with environment. If cognition is pattern recognition, what's to stop it from emerging entirely to unfamiliar forms? The deep sea, stable and ancient, could harbor collective systems far slower or broader than any animal. Imagine microbial webs communicating through chemical pulses, or vast mat-like organisms exchanging information across miles via electrical fields. To instruments, such processes might look exactly like anomalies we've recorded. Swarm networks, from ants to neurons, demonstrate that simple units can create complex adaptive intelligence when linked. The ocean already exhibits cooperation. Coral reefs share nutrients. Microbial clouds respond collectively to stimuli. It isn't difficult to imagine the scaled up, beyond sight, behaving as environmental thought. This isn't fantasy. It's statistical potential. Given billions of years, life adapts to every niche: sound, vibration, electricity. It all could become languages of survival. Whether we interpret them as communication or coincidence depends less on the ocean's behavior and more on our readiness to recognize patterns outside familiar definitions of mind. While we craft spacecrafts to send greetings across galaxies, we've yet to decipher the messages rising from our own oceans. Voyager's golden record carries humanity's voice into the dark, but few realize the sea beneath us has been broadcasting for far longer. Earth's marine environment predates land intelligence by billions of years. If communication exists without speech, if awareness can span ecosystems, the ocean is its natural birthplace. It's stable, shielded, and enduring. It holds continuity space can't match. Our ambition faces irony. We hope for extraterrestrial contact, but ignore unexplained signals here. Hydrophone data might not be cries from alien life, yet there are certainly signs of complex planets speaking through physics that we don't fully grasp. The search for meaning beyond Earth should begin beneath it. Listening inward may reveal how communication first emerges from chaos. Perhaps then, when we look upward again, we'll do so with new ears, trained by the same planet that raised our consciousness. Discovery is rarely cinematic, its analysis often tedious until contradiction appears. In 2023, Analysis studying Philippine trench recordings noticed a repeating pulse exactly every 1.5 seconds. It lasted nearly an hour, steady, unwavering. No ship or quake matched it, because the timing between intervals followed prime number sequences. They labeled it as signal pi. The next day, a small geological tremor occurred nearby, immediately after the signal ceased. Was it coincidence? Data error? Statistically, perhaps, but the precision remained uncanny. Subsequent simulations could not recreate the same amplitude with random noise. Events like these embody modern exploration, the constant interplay between evidence and uncertainty. For every solution, another question arises. For every confident explanation, anomalies multiply. Science lives in that tension, not in certainty. We have learned to measure the unknown more accurately than we understand it. Faced with the deep's mysteries, humans alternate between wonder and dread. The unknown invites both perseverance and suspicions. Psychologically, we need visibility to feel control. The abyss denies that. Its darkness and vastness turn uncertainty into imagination. That's why even trained researchers speak of unease listening to deep ocean recordings alone. Noises that sound aware resonate deliberate. Throughout history, our stories filled those gaps. The siren, the leviathan, the lake whispers. Myths mirrored reality, not necessarily in literal truth, but in emotional accuracy. The ocean evokes the same mix of reverence and fear today that it did thousands of years ago. That reaction isn't irrational, it's evolutionary. What we can't explain warns us to pay attention. Mystery becomes a form of survival. Whether the signals represent known physics or something deeper, they awaken an old instinct, which is to listen, to question, and to imagine. Every year, instruments push deeper. New drones descend autonomously, surviving under pressures that would destroy earlier crafts. Equipped with AI, they analyze acoustic waves directly on site rather than relying on fragile radio feeds. Next generation sensors will soon detect atomic scale vibration, allowing scientists to separate background turbulence from structured harmonic sound. With that precision, we may finally determine how certain frequencies repeat, or why they do. But clarity begins with responsibility. If the ocean truly communicates through resonance, how should humanity behave as the listener? Should we attempt to respond, generating artificial signals to mirror them, or remain observers? Technology gives access, but not wisdom. The ocean's depth demands respect equal to curiosity. Our species may soon stand at the threshold of understanding phenomenon once thought as a myth. Whether we step through wisely remains to be seen. Long before sonar, sailors told of hearing voices under the still seas. They called them spirits or omens. Across cultures, legends describe the sea as speaking. Modern data doesn't disprove these tales, it reframes them. What listeners once called song might have been infrasonic pulses or resonant tides traveling vast distances. Myth translated direct experiences into story. Comparing those ancient reports with today's anomalies reveals communities of awe. People sense patterns long before they could graph it. We now measure them with what they felt, and still the result escapes full explanation. Perhaps myth and science are complementary perspectives, one emotional, one analytical. On the same ecological truth, the sea has voice, rhythm, and persistence. When we analyze its signals mathematically, we participate in storytelling too, not of gods or monsters, but of nature exploring its own depths through us. Picture scientists aboard an expedition vessel at dusk. Instruments are quiet, oceans stretching infinitely. The day's recordings are done, anomalies are logged, theories are exchanged, yet the question endures, what exactly did we hear? Descending again in thought, imagine traveling miles down into silence layered with pressure. No light remains, only slow movement, endless dark, and a faint vibration echoing through the sensors. Perhaps somewhere in those frequencies lies a message, unintentional but profound, a signal that existence itself creates simply by being immersive and dynamic. What the ocean doesn't speak in language, maybe it lives in conversation with the planet. When we listen, we touch the rhythm briefly, trying to interpret it with limited comprehension, whether it through sound, light, movement, or energy. Something beneath us continues to whisper data, patient, consistent, and timeless. Our task is modest, to keep listening without insisting on conclusion. The deep sea does not reveal, but it reminds. Mystery isn't absent of answers, it's persistence of wonder. And in that same sense, the ocean will always be seeking. Our understanding just hasn't reached the right frequency yet.